Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Fabric 1.21. And in this tutorial we're going to be creating a custom block entity renderer for our block entity with an inventory. So all we're going to do in this tutorial is we're going to effectively create a chest. So we're going to have a custom Java model, and we are going to render that inside of our renderer, and then we are going to have that open with an animation whenever we open and close our chest. So our animation is actually going to be done by code rather than through Blockbench. So we are going to do that manually, and we will have a tutorial in the future that will cover custom keyframe animation. So let's go ahead and get started. The first thing we're going to start with is actually our model itself, since there are a few things to mention with this. So I am here in Blockbench and I've created a new model. Now, when you're creating a model, you need to actually make sure you create a modded entity model, and that is very, very important since we need to use an entity model to render how we want it to render. And actually, before you do this, you are going to need a plugin. So we're going to need to come to File and then Plugins, and then inside of Available you'll need to look for the Fabric plugin. Now we actually don't have that in Available because I already have this installed, but you need to look for the Fabric modded entity plugin and make sure you install that. Once you've done that, you can create your new model. Once again, modded entity, create model, and then in the export version, you need to make sure it is set to Fabric 1.17 plus, and you also need to untick the flip y-axis since we don't need to do that for our model. Then you can choose to fill out the file name and the model identifier if you wish. I generally just leave those blank since they're not a big deal. Now, when you're actually creating your model, there are a few very important things to note. So this is my model here. It's just literally a very basic chest kind of model, since I think that's going to be the easiest to cover in this tutorial. The most important thing is that all of your model must be inside of a root group. So effectively groups, these will be by default called a bone. These groups define what parts should be inside of your model, and each group will be able to be rotated separately. So for example, here I have the main part, right? Now if I rotate this main part, that will rotate our entire model. So that's basically going to function as our root part. Then inside of this, you can see I have this cube, which is just this bottom part that doesn't need to rotate separately from our actual main cube. So we just have it inside of the main. Then inside of the main, we also have the lid. Now this needs to be able to rotate independently of the rest. And so if I rotate this lid part, you'll see that I can rotate that, and then I could rotate the main, which would still rotate that and keep that rotation of the lid. So in my case, I need to ensure that this lid is a separate group to the main. And you'll see inside of it, I have two parts. I have just this lid part, and then I also have this little like chest front piece as well. Now, another thing to note is that you want to make sure you set your pivot points. So on the main here, I have the pivot point. If you go to the pivot tool, you can see that this is in the very center of the model, since that's the place that we want it to rotate around. Then if I look at the lid, you can see I have the pivot point set to the very back here so that it can rotate around that point, rather than if I had it in the center, it would rotate around this point, which is really weird. So we want to make sure we have our pivot point at the correct location so that it can rotate around that point. I should also mention it's important that your name of these cubes are correct and they're not something weird. So for example, you cannot have a cube that starts with a number. You cannot have a cube that is called like static or any kind of Java keywords. They have to be different to that. So for example, if I named this cube static, that would not compile when we go ahead and export the model, since it's going to create a field with each of these cube names, and we obviously can't have a field with the name of static since that's against Java's rules. So we have to make sure that you are naming these correct. I know that's probably going to be a niche case for most of you, but just make sure that you do name them something that is allowed as a variable name in Java. Then you need to go ahead and obviously make sure you create your texture. Now, I'm not really going to create a texture for this because I'm awful at texturing pretty much, but you do just need to create a texture. So all I've done is I've just gone create texture, and then I've added some padding here as well, so I can easily do that. And then I've just confirmed, and I've got this texture here, which is just a template texture. And then I can obviously go ahead and save this as a PNG. Another thing I will mention is it's quite important that you make sure the front of your model is facing north. So if you don't have these coordinates here on the ground, which you may not have, then you'll need to make sure you get this cardinal plugin here, which will go ahead and show those views, which will go ahead and show the directions of each of the sides of the model. So you can see that this one is the north direction, so that needs to be the front of our model. And if you don't do that, then you might have some weird rotation problems when you actually go into the game and we use our model. But I'm now done with all of that. So what I'm going to go ahead and do is go File, and I'm going to press Export, and I'm going to export as a Java entity. Then I'm going to go into the correct location on my disk. So I'm going to go into the client package, and then inside that I'm going to go Java dev 30 tutorial mod, and inside of here I'm going to create a new folder, and I'm just going to call this model. And then inside of there I'm going to put the name of my model. So mine is just going to be an example chest model, and I'm going to press save, and then it will prompt you to say that you cannot re-import this model back into Blockbench, so you need to make sure you save this as a project file. So if we go ahead and click save, you see that this saves it as a BB model, and that is very important because the BB model is how you'll be able to import this back into Blockbench if you ever need to make any changes to the model. Since once it's exported as Java, we can't reverse that action and go back into Blockbench with that Java model. So we need to make sure we save it as a BB model. Otherwise, we could completely lose our progress if we accidentally exported it and then closed Blockbench. We would have a problem. So I just like to put this kind of in the root of my actual mod folder. I like to create a new folder in here, and I just call this BB models, and then I save my BB model in that folder. So once we're done with that, and we've ensured that we've saved our BB model and also saved our texture, which I'm going to quickly go ahead and do. So I'm going to put that in source, main, resources, assets, tutorial mod, textures, entity, and I'm going to create a new folder inside of here. And I'm going to, in fact, we don't need a folder inside of here. I'm just going to call this example underscore chest. There we go. So now we can go ahead and close Blockbench since we don't need anything else, and hopefully those will all have loaded inside of IntelliJ. We can obviously just make sure that those are in here, which they do seem to be. So now if we go into our client source set, which is up here, Java, and inside of model, you'll see we have our model. Now we are going to need to fix a bunch of different stuff in here. So I'm going to quickly go ahead and just remove some stuff there. And we're going to need to add the package declaration at the top. Then we are going to need to extend model instead of entity model. So that's the first thing we want to do. And that is model from net.minecraft.client.model.model. And then we're going to remove this entity here, since this is not a generic class anymore. Then we're also going to need to obviously rename this to be the name of the file. So that is example chest model. And we're also going to need to fix the constructor with that as well. Then you'll see that we also are going to have a issue with the super in here. So we need to make sure we super. And in here, we need to pass in a render layer. So what we're going to do is we're just going to say render layer, and I'm going to use get entity solid for mine, since my texture is fully solid. However, if you do have transparency or whatever, then you need to make sure you're using the correct one. So you might have cutout, for example, or you might have alpha, you might have translucent, you might have translucent coal. It's just whichever one will work for you. If it's not working, then I recommend you just play around with these and see which one will get you your result. It's probably going to be translucent, cutout, or solid. Those are generally the ones that you're going to want to use. Then we are going to go ahead and remove our set angles method since we don't want that. And then we're going to need to fix the render method. So for this, we're just going to want to get rid of these 4 floats for the color. And we're just going to say int color, and then we're going to need to go ahead and fix that inside of main.render. Okay, then I'm just going to go ahead through our get textured model data method here, and I'm just going to format this to make this a little bit easier to read if we ever need to modify any of this. Okay, so I'm pretty happy with this. I think this is all much better and easier to read. Now we are going to quickly go ahead and create a method to get our lid here. So generally what I like to do is I like to create a record which contains all of my parts. However, we're not going to be doing that since we only have 2 parts and only one of them is actually going to be rotated. So I'm just going to create a method to get the lid part. So I'm going to say public model part, and I'm going to say get lid, and that is just going to return this.lid. Then the other thing that we need to go ahead and make sure we do is inside of the constructor here, you'll see that it's saying that main is inside of root, but it's also saying that the lid is inside of root. So this is wrong. We need to make sure we are using the main to get the lid, since if we remember our block bench structure, the lid was inside of our main part. So we need to make sure we fix that. And if you have more parts and more groups, then you need to make sure you fix that for each of those, and you need to get those right. Otherwise that will cause you lots of problems. Then the next thing we're going to do is we're going to create an entity model layer, do a public static final entity model layer, and I'm going to call this the layer underscore location, and I'm going to set that to a new entity model layer. This first of all is going to need an identifier, so I'm going to go ahead and use tutorialmod.id, and I'm just going to call this main, since that's basically this is the main layer, and then the name of this entity model layer will be the name of the model, so that is just example underscore chest in this case. And then I'm also going to create a constant for our texture location as well, so I'm going to do a public static final identifier, and I'm going to call this texture underscore location is equal tutorialmod.id, and I'm going to say textures / entity / example underscore chest, and that is a PNG file, so we need to say .png. Then inside of our tutorial mod client class, we need to go ahead and actually render this model layer. So I already have a little section here for the model layers because we had registered one for the boat, but all we need to do is we need to say entity model layer registry .register model layer, and we're going to say example chest model .layer location, and then we're going to say example chest model .get textured model data. And we need to actually convert this to a supplier, so we can just do like that as a method reference. The next thing that we need to do is actually go ahead and register a renderer for our block entity. So I'm going to create another section here. I'm going to say block entity renderers, and what we're going to do is we're going to say the block entity renderer factories .register, and then we're going to pass in our block entity type. So we're going to say block entity type init, and we're going to pass in the correct one, which is going to be our inventory block entity, and then we're going to register a renderer for this. So for the renderer, we're going to create a new class inside of our main package in the client source set, and we're going to call this renderer. And then inside of here, we're going to create a new class, and I'm going to call this example chest inventory BUR. And BUR is standing for block entity renderer. It's just a bit shorter, and there's no reason to make the whole thing. And then we're just going to pass that into here. So we're going to say example inventory BUR new. You see this gives us an error, and that is because we actually need to go ahead and make sure this class will implement block entity renderer, and that'll be of type our example inventory block entity. Then we need to implement the methods, which is just the render method, and then we need to go ahead and also add a constructor as well. So we're going to create a public example inventory BUR, and this will take in a block entity renderer factory .context, which is the context. Now we are actually going to use this context as well, so we're going to need to create a model that we will use. So we're going to need a private final example chest model, and I'm going to call this the model. Then we need to set this in the constructor, so we can say this .model is equal a new example chest model, and then we pass in context .getLayer model part, and then we need to pass in our layer location from our model class. So that is the example chest model.layer location. And that will go ahead and create the model. Then all we need to do inside of the render class is we need to say matrices.push. And then we can say this.model.render. And we're going to need to pass in the things it wants here. So that will first be the matrices. Then it will be the vertex consumers.getBuffer. And that will go ahead and pass in the render layer. So that will be render layer.get entity solid. And we're going to pass in the texture. So that is example chest model.texture location. Then it needs the light and the overlay. Then we need to go ahead and say matrices.pop. So the reason we are using entity solid here is because that's the same one that we used inside of our model file here. You see that we used entity solid. So that's the same one that we need to make sure we use in here. Otherwise that might give us some problems. Now, what does this do? Well, effectively, we are pushing to the stack. So we're saying to the matrices that we're going to start a new set of transformations. Then we are going to render using those transformations. Then we are going to pop the stack. So we're going to basically remove that transformation off of the stack so that the next thing that renders does not copy that transformation. Now, we're actually not making any transformations here, as you can see, but we are going to need to when we actually test this in the game. So what we're actually going to go ahead and do is we're going to start the game. And it's very important here that we are going to start this on debug mode, since we're going to want to make sure we're going to make some changes when we actually get into the game, since this probably isn't going to work exactly how we want it to. Alright, so we're in the game and this is our inventory block here, and you'll see there are some weird things going on here. So first of all, why is our model completely black? Second of all, why do we have this missing texture block here? Third of all, why is it in the wrong place? So these are all three very good questions, and we're going to try and fix all three of them. So I actually did completely forget that we're going to have this purple and pink missing block here, so we actually are going to have to restart the game before we can fix that. However, we should be able to fix the translation of this. In fact, no, let's go ahead and fix this missing block first, since that's going to help us try to fix the transformations. And we're going to go into our block class, and inside of here we need to say get render type, and we're going to return block render type dot invisible. Since we don't want to actually render the default model for this block, we're just going to give it an invisible. Then what we can do is restart the game, and once the game has restarted, we should now be able to see that we don't have that problem. Alright, so here we are, and we can now see that that has been fixed. So we can now actually see just an invisible block there basically, and we're going to need to move our model into that position. So let's go ahead and do that. So we're going to come back into our renderer here, and inside of this render method, we are going to say matrices.translate, and we're going to need to translate this by, well, let's try first. So let's just try 1, for example, and then we'll try 0 for the other ones, and we'll see what it does. So we're going to do that, and we're going to press Hotswap. Now, if you don't have Hotswap, this is actually from a plugin I am using, and this is the single Hotswap plugin. So you need to come up to File, you need to go Settings, then you need to go down to Plugins, and in the marketplace, you need to search for single Hotswap, and you're going to want this one here. And if you just install that plugin, then it will allow you to Hotswap a lot easier and a lot faster. So I can just press this Hotswap button as long as we are in debug mode, and we should be able to see that our model has been moved. Now, it's actually been moved a little too far there, so we can actually try using 0.5 and see if that works. So that actually appears to be in the right place in the middle, so then we can try moving it on the Z by 0.5, and let's see what that does. You see that's now in the middle, and obviously if we moved it on the Y, you could imagine that that would just move it on the Y like that. Now, we don't actually want it to move on the Y, since it's perfectly fine on that axis. So now, why is it so dark? That's the next problem that we need to fix. And the reason it's so dark is because it thinks this is a solid block. And so that means there's no light coming into this block. There's no light at the position this is being rendered at, because this block is a solid block as far as the game knows. Now, obviously we know that this is not a solid block, so we need to go ahead and actually tell it that this is not a solid block. So to go ahead and fix that, we actually need to come into our block class here, and we need to make sure we give it the actual shape of what the model will be. Since the problem is it thinks it's a full block, but in reality we're not rendering it as a full block. So we need to go ahead and actually tell it the size that it should be. And this will also go ahead and fix the hitbox and the collision box as well. So let's come into our block class here, and we're going to come at the very top, and we're going to need to create a voxel shape. Now, before we do that, actually, let's create a method that will allow us to get the shape. And the one that we're going to want is going to be the outline shape. And inside of this get outline shape method, we can go ahead and return the voxel shape. So we actually do need to go ahead and create a voxel shape that we can use. Now we could do this manually, and it's not too tricky to do that for a very basic shape, which we do have. But if you don't have a very basic shape, then you're going to need to actually generate this using your model. Now, how would you do that? So the way that we can do that is using Blockbench. So we can come back into Blockbench here, and if we open our BB model, which hopefully you went and saved, what we can go ahead and do is we can go ahead and press Export Voxel Shape. And if we choose the yarn mappings, now I should mention that you might not have this by default, so you once again will need a plugin for this. So you need to come to plugins, and you're going to need the either voxel shape generators, or also I believe there is a fabric voxel shape generator, so you can go ahead and install this one. There we go. And if we go export and we go voxel shape for fabric, we'll use that one, and then we'll come into, well, you can put this anywhere you want. Since we're going to delete this file afterwards, I'm just going to put this randomly on my F drive. Now if you open this file that it created here, then you'll see there is a method that creates the voxel shape. So for mine, I just have a very simple cuboid here, as you can see. So what I'm going to do is I'm actually going to take this part that it returns, and I'm just going to copy that out. However, if your voxel shape is more complex, then I recommend you take the method instead. And I'm going to come back into IntelliJ once again, and we're going to create this as a field. So we're going to say with a private static final voxel shape is going to be equal to either call that method or the internals of that method. Another thing that we can do after this is we can call .simplify, which will go ahead and simplify that voxel shape as much as it can. Now once we've done that, we can use this shape and we can go ahead and return this in get outline shape. Now ideally our block should be able to rotate horizontally, so we will need to actually do that. We're going to actually come into the game and we're going to see if this has fixed anything. And as you can see back in the game, this has now gone ahead and worked. Now for some reason it didn't work straight away. I had to actually place it, break it and place it back down. I don't know if there was something wrong with having the original one there or what it was, I'm not sure. However, this has worked, so that's fine. And you'll see our voxel shape is there as well, and that works as a collision shape and also as an actual outline shape as well. So the next thing that we need to go ahead and actually do is we need to create the animation for when we actually go ahead and open this. So how do we do that? Well, this is actually fairly simple. If we come into our block entity class and we come into here, all we can do is create an integer which will hold the number of players that currently have this open. So I'm going to come just below these and I'm going to create a private int num players open. Okay, and this will hold the number of players that have currently got this menu open. Then what we're going to go ahead in our inventory and do is we're going to override on open and we're going to override on close. And then inside of here, we're just going to say example inventory block entity dot this dot num players open plus plus. And then we're going to do the exact same thing in on close, but we're going to use minus minus. Then after we've done that, we do need to go ahead and make sure we cause an update as well so that we can sync this to the client. And then we're also going to need to go ahead and pass this around when we go ahead inside of to initial chunk data. So I'm also going to say mbt.put int, and I'm going to say num players open, and I'm going to pass in this dot num players open. Then inside of read MBT, I'm going to say if the MBT contains a num players open, and I'm going to say that is with a type of an integer. Then I'm going to say this.numPlayersOpen is equal mbt.getInt, and I'm going to say numPlayersOpen. Then we're going to also create another variable in here, and note this is going to be a client only variable, and this will be a private float, and I'm going to call this the lid angle. That's just going to hold the current lid angle inside of the block entity. This is only going to be on the client, by the way. So we're not going to save this. We're not going to do anything with this except access this from the renderer. Then inside of the renderer, what we're going to do is we're going to actually go ahead and grab the lid. So I'm going to say model part lid is equal this.model.getLid. Then we're going to need to actually access the rotation, and we're going to store this as a value. Now, another thing we are going to want to make sure we do is create a getter for both numPlayersOpen and the lid angle. So let's come down to the very bottom here, and let's say get lid angle and get numPlayersOpen. So inside of our renderer, we can now go ahead and access these two values. So I'm going to say int numPlayersOpen, and I'm going to say this is equal to entity.getNumPlayersOpen. Then I'm going to say the float lid angle is equal to entity.getLidAngle. Okay, so we're going to go ahead and make this lid angle here a public float instead of having a getter method, since I think there's no need for a getter method. This is only going to be accessed by the block entity. So this is going to be the lid angle, and that's going to be in radians, and that's very important that that is in radians. So we access that inside of our renderer here, and then what we're going to do is we're going to get the max angle. So the max angle that I want is going to be 110 degrees. So we're going to say a double, and I'm going to call this the max angle, and I'm going to set that to math.toRadians, and I'm going to put 110. And actually, let's make this a float. So let's just cast this to a float. There we go. Then what we're going to say, if the number of players that have the chest open is greater than 0, and the lid angle, so that's the current angle of the lid, is less than the max angle, right? So if it's like trying to be opened right now, then what we're going to do is we're going to change the lid pitch. So we're going to say lid.pitch is going to be equal, and we're going to use math helper, and we're going to lerp this using the tick delta, which is the delta time between basically the ticks and the frames. And I'm going to divide this by about maybe 4, since if we don't divide by 4 or divide by anything, then this is going to go super fast. In fact, by default, we'll leave it as just tick delta, and we'll try dividing it by 4 afterwards, and we'll see what changes there. So we're going to pass in tick delta, which is the delta. Then we're going to pass in the start. So we're starting from the lid angle, and we are going up to the max angle. And that's what we need. But then we need the opposite, right? So what if the number of players is 0 and the lid is still open? So we're going to say else if the number of players open is equal 0 and the lid angle is greater than 0. So that means the lid is currently open. Then we're going to basically need to do the opposite. So we'll say lid.pitch. We're going to set this equal to math helper.lerp, and this time we're going to lerp using the tick delta, and we're going to lose the lid angle once again. So that's the starting point, and we're going down to 0. Now obviously you might not want 0 if your pitch by default is not 0. So one thing you might want to possibly do is you might want to have a float maybe here and say float previous, or you might say default lid angle, and that's going to be equal to lid.pitch. And then what you might do is say between lid angle and the default lid angle, and that would mean that if your lid angle is not 0 by default, then it will go down to whatever your lid angle is. And once again, you might say here, instead of lid angle greater than 0, you would say default lid angle. We can do that if we want. In fact, we will do that just for the sake of consistency, I suppose. Then we're going to need to actually change the lid angle in the block entity so that it remembers that the lid angle was changed. So we're going to need to say entity.lidAngle, and I'm just going to set that to lid.pitch. Then after we render it, we're going to want to reset the lid angle on the model. So we're going to say lid.pitch, and we're going to set that back to the default, or in our case, that will just be 0, but we're setting it back to the default to what it was before. And the reason we need to do this is because this renderer will actually be used for all of our block entities that share this renderer. So this exact same instance will exist for all of them. And that means they all have this exact same model. So if we change any variables on this model, that means that it would actually change for all of them at the same time, which is super weird, of course, and you don't really want that. So what we do is we change it like this, and then we render it with that change, and then we reset it back to what it was before. And that allows us to have independent renderer and independent changes on the model per each rendering instance. So if we go ahead and we actually hot swap that, we should be able to now see in the game that if I open it, you see that it opens the lid, and actually it's resetting it back for some reason. So it turns out the reason that you can actually see it going back and forth here is actually because we casted this to a float. So this is actually an issue with floating point precision here. So it's actually not as precise for whatever reason using a float. So we could either convert this to have a little bit of leeway in there, or we could just use a double and convert it to a float when we need it as a float. So basically the check that is failing is this if statement here, because the lid angle is not less than the max angle, because the max angle is a much more precise number when we're working with doubles. So what we can do is we can just make this a double, and we can not cast that to a float, and then we can just cast it to a float inside of here. So we can either cast the math.lerp to a float, or we can cast the max angle here to a float. I'm just going to cast the max angle there to a float, and if we hot swap that, you can now see that it stays in place, and if we close it, you'll see that it zips back, so it lerps back to the exact place. Now, as I say, this is way too fast, so we could, for example, divide by 4, divide the tick delta divided by 4, and if we do that and open it, you'll see that is much slower. It still might be too fast for you, in which case you can obviously divide by a bigger number, and that will make it go much slower, which is actually pretty cool. Probably not what we want, but it's pretty cool. And also you might notice that the easing here is maybe not exactly what you want, so you might want to use a different lerp method for yours. You'll see there are a bunch of different lerp methods in here, or you can obviously write your own. It's not too complicated. As you can see, it's just a very basic lerping in here, but you might want to use a different easing method if you so please. So the final thing I'm actually going to do, and this tutorial I know is already quite long, but the final thing I want to do is actually make this block rotatable, and we're going to go ahead and do that real quick. So we're going to come into our block class, and what we're going to do is we're going to create a public static final, and this will be a direction property, and I'm going to call this facing, and that is equal to properties dot horizontal facing. Then we're going to set the default state in the constructor, so set default state to get default state dot with facing, and we're going to say direction dot north. Then we are going to override get placement state, and in here we're going to return the default state, and we're going to say once again with our facing property, and we're going to say context dot get horizontal player facing, and we're going to say get opposite, since we want to place it opposite to the way that the player is facing. Then we're also going to want to override rotate and mirror, so I'm just actually going to paste these in for brevity, but you see here that we are just saying that it basically will put the facing to rotation.rotate, and it will get the facing. So that basically will automatically go ahead and handle that for us using the block rotation and block mirror enums respectively. Then we are also going to want to override append properties, and in here we're just going to say builder.add, and we're going to add our facing property to the block state properties. Now that is going to be pretty much it. However, our get outline shape is now going to be wrong for certain directions, so I'm going to actually go ahead and paste in a utility method that we're going to use for this. So first we are going to need to create a private static final map of direction to a voxel shape, and I'm going to call this the shapes is equal to a new hash map, and we're going to rename this shape up here to be the default shape. Now the method that we want to paste in here is going to be this calculate shapes method, and what this will do is it will effectively go ahead through each of the directions, and it will go ahead and calculate how it should rotate that shape using the direction. It's a little bit of math here, and it's a little bit complicated if you're not informed with it. I wouldn't really worry about it too much. Just note that this is the method that you will need to copy in. And then in our constructor, all we need to do is say direction.values, and then we're going to type .for, which will convert that to a for each loop. And then inside of this loop, all you need to do is say shapes, and we're going to put the direction, and we're going to call calculate shapes, and we're going to pass in the direction and the shape, which is just the default shape. Then what we need to go ahead and do inside of get outline shape is we're going to return shapes.get, and we're going to pass in state.get, and that'll take in the facing. So that'll basically say it will get the facing property, which will be a direction, and it will pass that into the shapes, which will get us the rotated shape, which is the calculated shape here for each direction. And the important thing is that we do this in the constructor so that it only runs once. Now, if we go ahead and run the game, we should be able to see that our shape will be rotated. However, we are going to need to fix our renderer as well to make sure that when it's rendered, it's rendering the model with the correct facing property. Okay, so here we go. So if we place it down, we can now see that it's actually rotated the shape there, and that happens for each direction as well, which is great. So that's exactly what we want. Now we are going to need to, as I say, fix the actual rendering, since you can see when it rotates, it still shows the kind of knob on this side rather than on this side, which it should be. So let's go ahead and fix that. Now, luckily that will be super simple. So all we need to do is write switch, and we're going to switch on the entity.getCacheState, and we're going to we're going to pass in our example inventory block.facing, and we're going to switch on this facing. We're going to say that in case east, we are going to say matrices.multiply, and we're going to pass in rotation axis.yp.positive y.rotation degrees, and we're going to pass in 90. Now, if it is the east direction, we need to actually rotate it by 270 here so that it is correctly rotated. And if we hot swap that, we can see that in that direction, this is now rotated correctly. I am actually using an if statement here instead of a switch. And the reason is because I can't hot swap in a switch statement because Java moment. So we actually have to use an if else to at least test this. And then obviously afterwards, we can switch it into a switch statement. So we can say if it is direction.south, then we're just going to go ahead and rotate that by rotation axis.positive y, and you can probably guess that this is going to be 180. And then else, if we are facing west, then we're just going to go ahead and rotate this by 90. And if we hot swap that, should now be able to see that for south, that's rotated, for west, that is rotated, for east, it's rotated, and for north, obviously, it's fine in north because that's the default direction. And you should be able to see that the lid rotates on all of these, and they're all independent as well, which is great. So that's pretty much what we wanted there. We can obviously switch this to a switch statement now. So that is going to be it for this tutorial. I hope you guys found it useful. I know this has been long awaited. People have been waiting for block entity renderers, and we are going to be going to them in a little more detail in the next few tutorials as well, so that we can like render items, render fluids, all those kind of things, which will be really fun. And possibly we'll also mess around with rendering quads as well, which is some exciting stuff. And obviously we'll cover keyframe animations as well, since I know a lot of people want to know how to make kind of better animations for these rather than just math animations, which is fair enough. We will also cover at some point fixing the item model, since now that we're using a block entity renderer, it can't use the parent item model since there is no parent item model. So we will have to go ahead and fix that as well. And for that, we'll use a dynamic item renderer, which basically is a renderer for items, or if you're used to forged names, that is a Boolean, which is a block entity without level renderer, but it's just dynamic item renderer in Fabric. So we will go ahead and get into those very soon as well. For the meantime, you can actually just use basically a JSON model for your item if you want. So what you can do is go into Blockbench and just basically recreate your model, but as a block/item model, and then export that and use that as your item model. That will work perfectly fine too. Obviously, I know that won't work if you have different rotation values or those kind of things, but for a model like this, that would be perfectly fine, and it would work perfectly fine doing that. So you can do that if you want. But yeah, that's going to be it for this tutorial. I hope you found it useful. If you did, please do be sure to give it a like and subscribe. And if you have any problems, feel free to join the Discord server, which is linked in the description below. And I will see you in the next video. Goodbye.